right, and then this brings us to the kinetic molecular theory of gases. Now, the kinetic molecular theory of the gases, there's a whole bunch of assumptions and a whole bunch of postulates that we're going to discuss when we get into gas laws. So I'm not going to bring up a whole bunch of them here, other than to know that the kinetic energy in a gas is so much higher than in the liquid and solid phase counterparts. Okay, and this is because gases have a whole lot of energy. They're constantly moving. They're bouncing off the walls of their container. They're bouncing off each other. Think of them as like cue balls in pool. They're just bouncing and moving all around. So gases have expansion. All right. So gases do not have a definite shape and they do not have a definite volume. So this means they're going to both take the shape of whatever container you put them in and the volume. So gases are going to completely fill the entire container in which they are closed in. So if I took a gas like oxygen and I put it in a container that's 5 liters, okay, that means that gas is 5 liters in volume. If I took the gas and I poured it into a container that only had 1 mil of volume, that gas would then conform and fit the shape of that container and only fill 1 mil and have a volume of 1 mil. So because of this expansion and because of the fact that they are going to expand and fill the entire container, depending on whatever container you put them in, what is going to keep the gases in our atmosphere, right? So why are all these gases, the nitrogen, the oxygen, the hydrogen, the carbon dioxide, why are they not expanding and just floating out into space? You ever wonder about that? Well, the reason is because Earth has something called gravity. Remember, it is these attractive forces that keep molecules together. So the more attractive the force, the closer they are together. Because we have gravity, gravity is going to keep our molecules in our atmosphere.